Good morning and welcome to the 29th Annual Exhibit of Hydrogen Fuel Cell Technologies at the Hanover Fair. The technical forum is for technology and technical explanations. Here we go into details. That's the difference between the public forum, which is more for journalists, and here it's for people who understand the innards of this technology. To give you one example, leading experts in bipolar plate solutions. We'll be talking to Peter Roth, who's product manager of BBP Fine Tool, and Martin Florstedt, business division manager at Syntec. Please welcome.
Thank you. Yes, hello. Thanks for having us. My name is Martin. I'm working as a business development manager at Syntec, and I'm taking care of our hydrogen activities.
My name is Peter Roth, and I work as a project manager for bipolar plates manufacturing at Fine Tool. And Fine Tool is a company with over 60 years of experience in production of precision metal parts. And we have a huge track record of producing up to 3 billion parts every year. And it all started with the founder introducing fine blanking as a cost-saving process in mechanical typewriters. So obviously, the company had to undergo significant changes to be still present today. The main market afterwards became automotive industry, as our processes are typically optimized for high volume, cost-effective production. So what you can see here is one example of clutch plates, which we produce in the millions every year for any kind of transmissions in cars. And lately we became a major supplier for motor cores in the electric drive of battery electric vehicles. But that's not what I want to speak about today. We want to speak about the future application in metal precision parts for hydrogen. And when we started the development project for mass production of those parts, we came across company Syntec quite quickly, and we were very happy that we share a common vision.
Yes, who is Syntec? Syntec is a medium-sized company from Germany. We started more than 30 years ago as a design office and have developed into a globally operating production company. We are producing machines and we are producing parts in large quantities. With our 300 employees, we run facilities in Germany, in China, and in the United States. Our core competences lie in the automated assembly and in the laser manufacturing of automotive and medical components. Unlike Fine Tool, we did not start with typewriters because typewriters were already outdated when Syntec was found. So we focused on machines and components for internal combustion engine-driven vehicles. So you see their shift forks, for instance, they are used in automatic transmission systems. You see their laser-welded gears. You see their diesel injectors, where we delivered machines to produce a lot of sub-assemblies for this. And we also were focusing on any kind of pump, like cooling water pumps and gasoline pumps in the past. So now we all know that internal combustion engine cars might not be the future anymore, so we had to find new business fields. And for us, hydrogen application seems to be one of this, and we are quite sure about this. So today we want to talk about our hydrogen activities. We did not start thinking about hydrogen activities today. We built our first machine in 2006. It was a machine for the laser welding of metallic bipolar plates and have delivered several laser welding machines so far. Since 2012, we are producing SOFC interconnects at our facility in Chemnitz and also PEM bipolar plates in large quantities. We are doing this on our own equipment, so we are a machine building company, but we are also a producer. We are doing this on our own equipment, and there's of course a need to develop ourselves, to develop our laser technology, to develop our machinery. And in order to do this development, we need raw material, we need parts, we need precise formed parts. And as we alone, as Syntec, are just one part of this process flow, we are happy to team up with Fine Tool there because they are the experts for the fine forming of thin metal sheets.
So now we are going to look at how does this work. You're going to see a video about the fine forming process. First, you see the latest generation of fine blanking press, FB1. You will see it's installed in our headquarters in Switzerland in the tryout area, running our own development plate, demonstrator plate in in a demonstration tool. And as you can see, those tools are very compact in size, and we are working in a minimum amount of production steps. And now we are going to focus one important aspect of the accuracy of those plates. So when you take an anode and a cathode and you weld them together, it's very essential to have flat, also big flat surface areas, and also a very good alignment of those parts to be able to weld them. On the other side, the stack does care about other features of such bipolar plates. So a very uniform, homogeneous channel height is very important for the stack function, so that every channel has really the same height. And on the other side, that we achieve a very uniform material thickness after the forming. So the more uniform this forming can happen, the more you can reduce the thickness of the material, and by that save weight and also money. Additionally, we are very close to square channel structures with small radii, which is very good for the function of the stack, and as already mentioned, those reference geometries for the laser welding. So how to achieve this? One aspect is force. As we work with high forces, even for those very thin metal parts. And here you see an example for a 300 square centimeter plate, also active area of the plate, in which around about 720 tons are used in the coining stage in order to get really the full flat surface of the coins, and not a round shape at the end. In order to achieve this, it's also very important that these coining elements have a very good support in the press. So we work on small tables in a very central position, on very rigid presses. Actually, you can visit us on our booth. We have half of the tool here. So if you're interested, you can have a look at it on how this looks in reality. Another aspect is the tool concept as such. So we do combine many forming steps and cutting steps, or operations, better said, also forming different areas, as well as cutting inner forms and reference geometries in just a few steps compared to other processes. And very essential and pointed out here is that the final shape to the flow field is given really at the same stage as the reference geometries. And by that, those two elements in relation to each other are as accurate as the elements which form them. And this is really where we bring also benefit then back to the laser welding.
Yeah, let's have a look at the flex welding and what makes it flexible. Back in the 2000s, our customers, they required machines which were used for prototyping, which were used to define welding strategies, laser parameters, and so on. With the flex cell system, we developed a machine in 2020 which is able to produce several millions of bipolar plates per year. With the combination of laser sources and optical components, we are able to weld any welding geometry. We are able to deweld several dimensions, so we are quite flexible in terms of the welding, but we require high precise formed metal sheets in order to make the biggest use of the channel. What we require is a flat channel and a zero gap between the two plates. So with our flex welding, we are relying on a two-step welding process. Everything runs fully automatic. The parts are handled by robots, and all the welding operations are followed by a leak testing and an optical inspection. Here you see two typical weldings which are performed by our flex cell. So first of all, we have to create a leak-proof outer welding seam around the bipolar plate, and very often we also have to do some spot welding within the flow field. That there is not much space for clamping and for welding itself. You can see on the little red spot within this green flow field geometry. So this area has to be very precise because we need it for the welding, for the positioning of the welding seam, and we need it for clamping. We have to create the zero gap between the two plates, otherwise we will make holes, and instead of we will do laser cutting instead of laser welding then. So what is essential for us? So first of all, we need high accurate laser optics, of course, in order to position the beam directly where we want to have it. Then we need precise fixtures and tools in order to align the two plates. They are not welded together, they are single. So we have to align them together within the fixture and in order. And last but not least, of course, we need accurate, very accurate form geometries. And those form geometries are supplied by FineTool, and Peter already explained how they are going to do this.
Mm-hmm. So now let's have a look on typical development steps in a project. So first, there's a feasibility study performed by both companies together. So we look at the forming and the welding aspect together, and I think that's also something, a benefit of the cooperation we can bring in additionally, because usually these two elements are somewhat treated separately. And here the target geometry is verified. We can run simulations, of course, and if required also to pre-test on smaller geometries to not build directly the bigger tools with higher costs. And this prepares then for prototyping stage, where really plates are produced, the manufacturing processes are validated, and of course the customer can test those parts in his stack and get the functional feedback and acceptance for these steps. So based on this, a pre-series production can happen where already automated tools are then used, and for the welding and for the inspection serial machines are used, and here we can already deliver up to several 10,000s of plates to build more stacks and prepare for the final step of serious production, where then for every process step, serial production machines are used, and the fuel quality assurance and quality control is implemented. So a typical process flow on the process step, we see that everything which is required to produce anodes and cathodes are handled by FineTool.
And all the laser welding applications, the leak testing, the visual inspection, and as well a marking with a DMC code for all good parts, this is covered by CTEC. And we have to make sure that the adjustment between the forming and the welding is perfect, because otherwise we won't be able to deliver perfect quality. And this can be assured by our cooperation between CTEC and FineTool.
So additional processes like coating and sealing can be implemented project specifically, as there's not one standard which fits for all applications.
Yeah, there you see a visualization of our plant we are actually building in Taizang in China. So by the end of this year, all this will be running. We will use our own equipment in order to produce several millions of bipolar plates starting end of this year, 2023.
So to close the circle from the beginning of the presentation, together we will bring metal bipolar plates production solutions starting in Asia, Europe, and then hopefully the whole world. Together, Martin. Thank you.
Thanks for having us again. And we are happy to answer any questions here or at our booth then later on.
Yeah.
Thank you. Yeah, unfortunately, we're running out of time for questions, but this is another example. When the industry started, it was always the automotive industry that came here. They had the material sciences. They knew how to mass manufacture things. And this industry really needed the cooperation with the automotive industry, which was so much larger at the time. So it's great to hear there's a cooperation like this. Join them at their booths to discuss what can be done with this cooperation. Thank you very much.
Thanks a lot for having us.
Thank you.
Thank you.
Bye-bye.